status of embodied carbon efforts in Wisconsin. Certainly isn't all of the things that are taking place, but trying to give everyone a general idea of some of the things that are in progress to advance the reduction of embodied carbon here in Wisconsin. We have a number of new faces on this call, so thank you for joining us. And just as a quick overview, the Carbon Leadership Forum is addressing embodied carbon, which is the upfront climate impact of building materials and the process of building the building. So the operational side is after the building is already in use, and everything up to that point is sort of lumped under embodied carbon. And it's a really critical piece of the picture as far as addressing the climate impact of the built environment. And so the Carbon Leadership Forum is a group that has arisen out of the University of Washington, but is now national and international. And we are a local hub, so there's hubs all over the country. And there we go, hubs all over the country. And the Carbon Leadership Forum develops materials for architects, engineers, policymakers to look at embodied carbon and how to reduce it, and has a very large library of resources assembled from a lot of different partners, as well as the things that they have researched and put together themselves. So if you haven't already checked out the Carbon Leadership Forum national site, please do. So we are a local hub, and we extend just for Wisconsin, but often try to do things as well with Twin Cities of Chicago going forward. We're pretty new. We've just gotten launched in the last 6 months or so, and are excited to bring this opportunity to connect here in Wisconsin. We have a new website, and it's still a work in progress, but has information about upcoming events, as well as links to the Carbon Leadership Forum library. So be sure to check that out if you have not already checked that out. Let's see. There we go. Goals of a Carbon Leadership Forum hub: to bring people together, to offer educational programming, to help identify possible action items as a group that collectively could help advance the issue of reducing embodied carbon, and also just to help everyone connect and figure out what resources work, what things are going on, and what we can learn from the examples going on around us. So hopefully it's an opportunity for all of you to incorporate thinking about embodied carbon into your work in whatever way that is the most relevant. So it's a wide range of professionals coming from a variety of building backgrounds, everything from materials to the design side, to carbon calculation, that sort of thing. So really, we welcome anyone who's interested in learning more about this and how we can reduce embodied carbon.
Thanks, Julia. I'm Ben Austin with Vindorf, co-lead with Julia, and Kim Radine is our third as well, who's on the call here somewhere. So the goal today, as Julia said, we have 4 major goals, but the goal of today is really to educate. So this is maybe more traditional programming from an educational standpoint, putting content in front of people who are interested in the topic to engage. So we're calling it case studies. Some of these are traditional, maybe case studies that you think of with buildings. Some of them are maybe less traditional, but again, it's work in the space of embodied carbon taking place here in Wisconsin. Again, trying to make it applicable to, I believe, the majority of us who are operating at least fully or partially within the state in our work. So we have 4 wonderful presenters, which I will hand it off to in just a minute. For those of you who've been operating in this space at all, you know that there are a number of acronyms that are important to understand. I'm not going to read through these, but these are, I guess, 6 that I pulled out as I was going through the slides for items that might require a little bit of definition. Some we'll get into, again, if you want to reference the slide deck at the end. These are important topics and metrics and tools within the space that you should become familiar with. And with that, I will hand it over to our first presenter, Unni, Unni, are you with us? It looks like you are.
Yeah, hey, Ben. Oh, you're muted.
It's all yours. Take it away.
Okay, and I apologize. I'm having a little trouble seeing the slides. I think I'm on my phone because I'm traveling. Is it the slide in yellow or the slide after that? Also, again, muted.
It'd be your first slide titled Motivation. Sorry, Unni.
Okay, perfect. Thanks. Yeah, so good afternoon, everyone. My name is Unni. I'm a PhD candidate at the University of Wisconsin-Madison. I work in the chemical engineering department doing research, but for this project, I've been collaborating with a professor in the civil engineering department, and we've been really interested in looking at this question of embodied carbon in the state of Wisconsin, inspired in part by sort of what Julia has done. Yeah, so I think one of the big things that professor that I've been working with has been interested in is this question of, given the environment we're in right now, federally, in terms of a lot of incentives driving sort of green procurement at the federal level, and as far as how that is trickling down to the state level, we wanted to understand how is the state of Wisconsin, both publicly and privately, ready to adapt to any federal changes in terms of mandates or requirements for green building. The motivation is partially due to this large increase in incentives through, for example, the Inflation Reduction Act, but also just the general, recognition that's growing that these Scope 3 emissions are, pretty significant in terms of global CO2 emissions, and so are going to eventually be a large focus of the government, even if they aren't right at this moment. Next slide, please, Ben. So for our work, what I did is I reached out and spoke and had a lot of in-depth conversations with folks both in the public and private sectors. So this included engineers or supervisors in large cities in Wisconsin, also experts in public works projects, people associated with sustainability and purchasing, and finally folks in the private sector, Flad and Findorf. And next slide, please. And so the results are as follows. This, let me preface by saying this is a brief canvas of what is obviously a really in-depth issue that many people have been focused on. But I think it was helpful for myself to break it down into this facet. If we look at the overall sort of embodied carbon emissions that are sort of associated with construction and infrastructure, about 2/3 of those are associated with private construction, and 1/3 are associated with public construction. This is straight from the Carbon Leadership Forum. And so what we were interested in is if we wanted to understand how embodied carbon emission production would be affected by federal mandates, we needed to break down this private and public distinction further. And so what we realized is sort of there are a few camps with different abilities to adapt to federal mandates. So in the, if we focus on the private sector side, which I think we're going to hear some really good examples of in the following presentation, we have a lot of projects that would be considered negotiated. So projects where, the private contracting firm has the opportunity to perform a more detailed life cycle analysis to study what design and finally what construction might reduce carbon impact of a specific project the most. And towards that end, a lot of companies have been adapting different life cycle analysis tools, particularly for building construction, such as Tally. And then we have hard bid projects where there's already a design in place, and for example, general contractor is coming on to implement the construction. And in these situations, there is still an opportunity for carbon reduction through product swaps. So things where perhaps you swap out the use of one concrete for something with equivalent performance characteristics, but a lower overall CO2 embodied emissions due to, for example, how the material was sourced. So I think we'll hear some really nice examples of the private sector side. So the thing I wanted to highlight with this presentation is on the public sector side, if we think about what public works projects look like, there is a significant amount in this situation. There are frameworks that when we spoke with, for example, the city of Madison, folks are starting to look at the use of LEED in public buildings, and specifically LEED version 4, which does offer an option to use a life cycle analysis to look at the overall embodied carbon. But these are sort of optional. You're not required to do that even if you're using LEED version 4. So there's still quite a bit of work to be done on the public sector side. And I guess if we look even further at the sort of infrastructure side, so roads, sewers, sidewalks, etc. I think the surprising thing that I learned from all of this canvassing is we haven't seen any very widespread interest or use of frameworks that would look at embodied carbon in these projects. And perhaps this is less surprising to somebody who works in the space, but given that this is going to be, overall 1/6 of the global carbon emissions from embodied carbon, I think it's worth highlighting that, perhaps this is an area that CLF should think about focusing a little bit of efforts on as well, because maybe this is somewhere where there's quite a bit of opportunity. So next slide, please, Ben. And I think the other sort of set of takeaways that we would have after speaking with folks is I would highlight both bottlenecks and takeaways. So for the bottlenecks, what is holding us back from implementing further adoption of green procurement standards or readiness to adapt to green procurement standards? On the public sector side, really, it comes down to maybe what it always does, which is sort of there's a lack of public pressure to address scope 3 emissions. And so associated with that is sort of a lack of willingness to increase how much we as taxpayers are going to pay for things that inevitably will cost a bit more. And then sort of also something interesting, which is, these are really new frameworks that would need to be adopted by public sector organizations. So if the Public Works Department of the city of Milwaukee wants to use a LEED version 4, perhaps there haven't been a lot of projects that have been done with that so far. And so one of the takeaways associated with that is we really need to encourage example projects and sort of learnings between public and private sector in order to sort of reduce the friction of these sorts of projects on the public sector side. On the private sector side, inevitably, general contractors, design firms are going to be beholden to sort of what clients are asking of them. And so if you have a forward-thinking client that's really interested in reducing the carbon emissions of their project, that's great, and that's something that a design firm can work with. But if not, then we're sort of limited in that respect. And so the other big takeaway there is a lot of these pieces are starting to come together, but we're still in the process of that. And so perhaps there's room for improvement in the actual tools that are used. But it does seem like there is a certain set of tools that people are coalescing around. And I think we'll hear some examples of that today. So happy to talk more if there are any questions, but I think the overall takeaways are summarized as those. Thank you.
Thanks so much, Unni. Yeah, if you do have questions on anything Unni covered, feel free to throw it in the chat. We'll come back to that at the end. Unni, is there a way people can get a hold of the formal report? Maybe we can link that in. We can connect afterwards and provide a link to more detail if people are looking for it.
Yeah, absolutely.
All right, thanks. Over to you, Tim.
Thanks, Ben. Hi, everybody. My name is Tim Liebhold. I'm structural engineer at Flad Architects in Madison. I am for lack of a better term, the embodied carbon champion for our structural department. Sort of got in this through SC 2050. I'll talk about that in a couple of minutes here, but I work with our main sustainability lead, Kim Radine, who's one of the leaders of the CLF hub, to implement strategies and look at the embodied carbon footprint of the structural work that we do here in our Madison office, but for our national practice. So for the case study I'm going to talk about today, it's interesting. There's a couple of layers to this case study that I'm going to try and breeze through here quickly. But I just wanted to give a little bit of background on the actual project that we're going to be talking about. So UW-Madison, we're in 2018, 2019 budget cycle, is budgeted for a renovation and expansion of the current veterinary medicine school on the Madison campus. So what this image on the right shows in the foreground is 150,000 square foot new construction building with large emergency department expansion for the vet school, which also includes teaching spaces. And then the upper floors of this building include research spaces of various types up into high-level biosafety levels. The project also includes, in the left-hand side there, you can see a new arena for indoor horse evaluations and large animal evaluations, plus an expansion to the large animal treatment and care facilities on the back of the school. Next slide. So context-wise, the existing veterinary medicine school is there in the gray. It's kind of splitting the difference between the hospital area of the Madison campus on the far left of your picture, and then the core campus on the right. So the agricultural life sciences parts of the UW's mission are right there, kind of in the center between the two, bridging the divide there, so to speak. So next, you can advance. There's a little graphic. So the little orange that just popped in there is just sort of a graphic of what this project was. For various reasons, a decision on final structural system selection for the expansion took a very long time. I don't, was not my reason to know why it was taking so long, but it did. But what that afforded us the time to do was we were able to advance our analytical models, or our baseline analytical models there on the left, RAM structural system for anybody who's interested, for both a concrete structure and a steel structure for the expansion to nearly the DD level. So these are end of SD, early DD level analytical models for the same footprint, the same type of building. The concrete building ended up being a pan joist, one-way slab concrete structure with a steel penthouse. Excuse me, and the baseline steel building we were looking at was a composite steel, traditional composite steel construction building. So one of the interesting things we were able to do, because we had the analytical models, even though we didn't have a design or documentation model in Revit completed, by the magic of various plugins, so a RAM Revit link on one side, and then a link, I believe this was done in Tally actually, to take the rough Revit model, we could kind of get order of magnitude, formatting on the numbers there kind of changed, but we get order of magnitude understanding of the GWP for various structures. So 3.8 million kilograms of CO2 for the concrete structure, 2.8 for the steel structure. So, about a million, 30% increase to go with the steel structure, or with the concrete structure over the steel structure. So it was really interesting because we, at least here at Flad, had not had the opportunity to put our arms around the true magnitude of the difference between different types of structures. For various reasons, unfortunately, or fortunately, depending on your perspective, probably Chris at Lycon, who's going to talk next, is happy we went with the concrete building, but we did end up going with the concrete structure for this building. So I just wanted to present this bit of information as sort of the high level analysis that we can do. And one of the things that really opened our eyes to here at Flad is we're now in the process, we have a whole database of base studies for putting together project proposals and schematic level narratives. And we're in the process of including a approximate GWP impact on a base study level, so that we can start informing owners and other decision makers early in the project, so that global warming and carbon is another piece of the decision making puzzle, instead of we made the decision, oh, and by the way, here's the impact. So you can go to the next. So in the middle of this project, everything was getting shut down for COVID, which was a whole different problem. But the other thing that was happening is the SE 2050 program was really starting to kick off, which is the structural engineering, American Society of Civil Engineers effort to reduce embodied carbon in built structures to zero by the year 2050. So a lot of people are familiar with AIA 2030. And so AIA 2030 is initially focused on reducing operational carbon to zero by the year 2030, and has since developed some embodied carbon reduction goals beyond that as well. But SE 2050 is the structural profession's effort to really reduce the amount of embodied carbon in structures. I mean, depending on what you're looking at, construction is somewhere between 8 and 12% of global carbon emissions annually. So it's a big piece. So we were working on that, and part of what we had to do was we ended up having to report. That's that share number 3 there on the right hand side. Share our data essentially. So you can go to the next slide and report our projects. This is kind of a hard slide to look at, but basically the SE 2050 maintains a database of submitted projects by all the signatories. In the initial year of the signatory, you're required to submit at least 2 projects to the database, and then beyond that, it's the increase is sort of on your own. We've been through 2 reporting cycles. We've reported 6 projects to date. If you can squint and make them out, they're the red dots on there. It's very difficult, but you know, one of the things that we learned through our reporting was really the criticality of certain impact categories. And so this is sort of our whole building LCA, including all structural elements. And next slide. What it really highlighted to us was, where can we make an impact on improving the embodied carbon of our structures? So for the UW-VetMed project, all concrete accounted for nearly 70% of the GWP for that project. And that's just putting it in this format is really just eye-opening. For a 150,000 square foot, primarily concrete building, nearly 70% of our global warming potential came from our concrete. So knowing that, and also simultaneously working with the state and the campus to improve the way we design and specify buildings, we worked to identify target areas where we could improve the end result. And one of those was improving the specification of our concrete, and looking at the way the state master specification required reductions and what the limits of those reductions were. So we're kind of somewhat constrained within the framework of the DFD master spec, but we were able to get in some language of our own. And we were able to talk to different producers and suppliers about what the goals for the project really were. And you're going to hear from one of those suppliers next, and we ended up being on somewhat parallel tracks on this, but we looked at ways to ask politely for EPDs, environmental product declarations. We couldn't demand them, but we could ask politely for them. We looked at ways to increase the cement reduction. Cement is the big bad in concrete, so we looked at ways to increase cement reduction. And we also looked at some supplemental cementitious material replacement language that we could put in the spec. So that would be like, for example, carbon cure, or carbon injection, CO2 injection into concrete to capture carbon. So we were able to improve our specification and ended up, you can go to the next, getting a pretty solid reduction over our regional baseline in our concrete. So what's on the left there is the primary mix that was used in this project, which ended up being about on average 16% fly ash, 5,000 PSI mix, and comparing that to the regional average, which is the Great Lakes region of the Ready Mix Concrete Association, we saw that we basically had nearly a 30% reduction in the impact of the concrete. So it was just good. This is not And this is not anything that we tried or required over and above industry standard. And I think it's just eye-opening because one of the things that's happening right now is we're all trying to establish baselines. And it's really helpful to understand that the closer to real information we can get, the more informed decisions we can make about improvement. So you can go to the next slide. So what our regional average versus mix specific information showed us is that about 1.3 million kilograms CO2 reduction in greenhouse gas emissions, so almost 300 cars off the road in a year, which is kind of a nice way to picture it. But one of the interesting things here is we're all kind of grasping at straws because nobody that I've talked to knows exactly what the baseline from which we're trying to reduce is. So the baseline for this project was the regional average, and then we had, during the project, Lycon was able to develop mix specific EPDs, and so we were able to compare those to what our regional average were. One of the things the state spec also required actually was a comparison of a 0% replacement concrete. We didn't perform an LCA based on all of the concrete being 0% or 100% cement, but Lycon did actually end up producing an EPD for that situation. And if we wanted to, we could go back and say, what's a 0% replacement versus the regional average versus the project specific, and really see how much of an impact replacement has. So I think that pretty much wraps up everything I was going to talk about, but I could talk for a long time and go into all kinds of depth on different things here, but I just kind of wanted to highlight a couple of different ways that we're able to look at different projects and ways we can compare and contrast and achieve reductions in carbon. So, thanks.
Thanks so much, Tim. Chris, if you're ready, we'll hand the reins over to you.
All right. My name is Chris Winger. I work for Lycon. We're a ready-mix producer here in Wisconsin, and my segment is really on developing EPDs. So a bit of a historical background. This ties in pretty well with Tim's project he was just talking about. The Vet Med project was actually one of the first projects we saw that had detailed sustainability language other than LEED. They were listed as a specification option. And while we were already working on reducing the embodied carbon in our concretes, we weren't really in a position to provide verified sustainability options. We had a vague understanding of the sustainability movement, but we're just starting to get our feet wet. So our intent was to take a parallel path, kind of working in the background while that project was being built, and to actually develop a verifiable program to do that. So, there's many commercially available products that can help reduce carbon emissions. We had already been approached by several companies several years ago offering products to reduce carbon emissions. Some of these I'm sure you've heard of, some probably not, but as we were investigating these options, which is realize the primary goal of all these products is cement reduction. And at the time, these companies and products were making claims that they could reduce our carbon emissions by 3%, 5%, 10%, whatever. But we kept asking the question, reduce the emissions from what? What is, we at that point, and this goes back several years, we didn't really understand what is this number? How do I measure all of this? Next slide, please, Ben. And the answer to that is the global warming potential, the GWP, which is the equivalent to the CO2 emissions generated in the manufacturing of a product. So how do we know what the GWP of a concrete mixture is? Well, an EPD. So adding a product may enable lowering a GWP, but that does not necessarily mean that a concrete mixture is environmentally friendly as it can be. You're lowering the GWP. The EPD quantifies the environmental information on the life cycle of a product to enable comparisons between products fulfilling the same function. So concrete versus concrete. They provide a detailed analysis of, in our case, a concrete mixture. They're third-party verified and registered with NSF International. They take into consideration all the environmental impacts of producing a yard of concrete. And a lot of the products you can add to your mix, they can give you the reduction. But again, like I said, that doesn't necessarily mean you're doing well with your mix. So some of these inputs into the EPDs to generate the data, it's in stages. Stage A1, which is raw material supply. What's pictured there is a cement plant, and like Tim had mentioned, they're kind of the guys in the hot seat right now with carbon emission. Their kilns heat in excess of 2,000 degrees, so they're a significant source of emissions. Next slide, please. Transportation, stage A2, which is how we get our raw materials and products to our plants. Is it by truck, by barge, by rail, by boat? If we deliver and ship aggregates to our plant by train, we can do really a much better job than if, say, we're hauling it in dump trucks. It's just more economically friendly. Environmentally, and economically. So, and then stage 3 is the manufacturing. That's a picture of one of our primary plants in Dane County. And that calculates the emissions generated to produce concrete, including the heating and cooling. And again, our primary plants in the Dane County area are central mix plants, which means the concrete is actually mixed by an electric mixer in the plant itself. Most ready mix plants, the dry materials are dumped and loaded into the trucks, and then the trucks mix the concrete by their diesel engine. So the central mix plants, they mix the concrete, dump it in the truck, and the product is more or less ready to go. So once all that information is generated and third-party verified, the EPD is submitted to be registered. So this is just the GWP is extracted from the EPD then and can be used to compare against National Ready Mix Concrete Association regional benchmarks. So this is just a hypothetical project, I guess. Lists a few mixes, the mix design, how many yards of concrete, the GWP that we're producing with the mix, the National Ready Mix benchmarks, and then the green shaded would be the total savings. Again, this is a hypothetical, but that's kind of the way it works on that. So next slide, please. Where are we headed? We're currently pursuing the ability to develop EPDs in-house. Things are moving really quickly with this, and the learning curve has been pretty steep, and we want to have the ability to test various materials and mixtures simultaneously to see if it's worthwhile to even submit for an EPD. Right now, we're relying on third party to do a lot of this stuff for us, and the process as it stands now takes months. One thing I would add that's important is, we can reduce the cement content of our mixtures. It's important to evaluate how these changes will affect the performance, how they impact other project constructability requirements, such as pumping, placing, finishing, strength gain, scheduling. We can take cement out, but if we don't get our post-tension strengths within the desired window or finisher overtime costs increase, are we really helping the entire project team? So all of these aspects must be taken into consideration and addressed when designing these low embodied concretes. Sometimes it's not easy. It requires your trial mixes, testing, and all that concrete testing, as you know, takes a lot of time. There's a big movement to reduce embodied and understood by the entire construction team. So it's really, really important that the owners, design team, contractor, and ready mix producer are having conversations well in advance of bid lettings on these projects, so everybody has an understanding and we're all on the same page. And then my last slide here, this is just an example. This project started probably 2 years after the vet med. We're quite a bit further down the road. This is a current project we're working on right now, downtown Madison, and we feel we're on the right path here. So that's what I have. Thank you, Ben.
Thanks, Chris. The only comment I want to make on this is just that, right, these metrics start with a conversation that you and I had, right? I think that's a takeaway for me, is just to engage with the people around you on the topic. That's how, right? That's how this is coming to the forefront.
Absolutely. We're a lot farther down the road on this one than we were on vet med, and as you know, we're working on others now too.
And then one other FYI for the group, I was on a webinar, an EPA webinar last week. They're having another one next Wednesday, but the EPA is administering or managing the $250 million in the Inflation Reduction Act related to environmental product declarations. There are, I believe, some competitive grants for suppliers to access some of that funding. So I put the link in the chat to the event taking place next Wednesday. Jump on that if you want. Obviously engage with us at the CLF Hub. We'll try to keep this group up to date with that funding as they kind of figure out how it's going to be administered. All right, over to you, Nate.
Thanks, Ben. Thanks for having us. So I'm Nate with the Neutral Project. I'm one of the managing partners here, and we're a local developer based out of Madison, Wisconsin. And really our mission is around sustainability and reducing both the embodied and operational carbon emissions in the built environment. And how we do that primarily is by building with mass timber, but there's also other ways that we do that by using low carbon impact materials and then designing to passive house standards to reduce the operational carbon. But I know for today, we're going to talk mostly about embodied, so I'll stay on that topic. So we have our catalyst project that's called Baker's Place, and that's on East Washington. And that's a 14-story mass timber high rise. And really the really cool innovative thing that we did there is it's a hybrid structure. And so we're using steel for some of our columns, we're using concrete cores, but then we're replacing all of our beams and all of our decking with CLT and glulam. And right now that's a reduction of about 42%, including biogenic carbon. And so the impetus for why we, if you can go back to that slide, Ben, well, I'll get to a baseline real quick. Sweet, thank you. So the impetus for why we wanted to use mass timber is because it has this unique ability to actually sequester carbon. And the way that's done is trees in the forest are grown, and through photosynthesis, they take in carbon. And then when you take those trees down and you put them into a manufacturing facility and then put it into a building, you're in essence creating a carbon sink. And so I know there's a lot of we just got done talking about concrete, which is awesome to see that concrete is getting closer and closer to zero. And I know there's some concrete mixes that are even at zero. And so we're excited about that as well, because we're using concrete for our podiums and we're still using concrete for our cores. So the more we do on the concrete front is awesome, but we really think that mass timber is the future for kind of supplementing some of these other areas with steel and concrete. And so that's our thesis, is to use mass timber for this building, but then all of our future buildings as well. So for this building, we did a little bit of a case study and we got some funding from the USDA for an LCA that we're doing right now. And we just finished actually our first round, which Ben, you can flip to the next slide. And so we took essentially two scenarios. One was our baseline, which was concrete, and the other was mass timber. And this might be a little bit too broken down for some people here, but just to give a background on what an LCA is. An LCA is essentially a full analysis, a life cycle analysis of the building. and it breaks down the building into all of its constituent elements. And so for concrete, what we did is we put together a BIM model, and we broke all the pieces out into its constituent elements. And then we quantified the embodied carbon impact if we were to build Baker's Place as a concrete building. Then we went and looked at our actual building, which is a hybrid system with mass timber, steel, and concrete. And we broke it all down into its constituent elements and built it all back up and looked at the total embodied carbon of the mass timber. And we came to this great result, which, Ben, you can flip to the next slide. So the result was, if you include biogenic carbon, we're at about a 42% reduction. And what biogenic carbon is it's essentially what I just spoke about earlier, which is the sequestration of wood and the carbon stored in the wood. And so if you include that, we're at 42%. If you exclude that, we're at 20%. And really why we're at such a big increase, even if you exclude the sequestration of carbon, is because our concrete podium is so much less intensive, because the actual mass timber is way lighter than a steel or concrete structure, that you don't need as much in the podium itself. So that's one of the reasons. The other reason is that we're using some of these other low impact carbon materials that are really reducing our embodied footprint. So the goal for Neutral Project is that over the next 3 or 4 projects, we'd be able to get that 42% to hopefully 90 or even 100%. And as we progress and iterate on our design, we'll get closer and closer. And with the work that everyone else is doing here with Chris and the rest of the team, we think that by reducing some of the other areas like concrete and steel, we'll be able to increase that number and hopefully eventually get to 100% one day. So that's all I had. I know it was a shorter presentation, but happy to take any questions.
Thanks, Nate. I think there's one question from Don Thompson talking about end of life impacts for mass timber. I see Russell, I think you have your hand raised. If you want to, everyone should be able to unmute themselves if they have questions to ask. So Russell, why don't you jump in, and then Nate, maybe take a look at the chat at Don's comment. I don't know if you want to speak to end of life side after Russell asks his question, but go ahead, Russ.
Hey, Ben, thanks. 2 questions. First of all, the awesome projects. Thank you so much for the education. Excited about a number of these projects for many months now. Tim, if you could just say again, what happened to the existing vet med, or what's the plan with the existing vet med, and was that integrated at all with the new construction? I saw the map showing the existing location, but I didn't understand.
Sure. Yep. Sorry. So the total square footage for the project was about 150,000 square foot addition. We are renovating between, depending on the day and the scope as it goes in an existing structure, somewhere between plus or minus 15,000 feet of the existing structure building. So part of the new project, we're building a bridge to a parking ramp that was built on half of the site, and a bridge to the existing vet med school from ours. Ben, if you could go back to the first slide of my presentation.
But in essence, the existing vet med is staying and
yes.
is part of the okay.
Correct. So we are almost doubling their square footage of their facilities. And then the arena in the back, there is another about 60,000 square feet of indoor space.
Thank you, Tim. For the sake of time, in case there's other questions, I'll get to my point. I think clients are interested in embodied carbon. There's a story here that I didn't quite hear from you, which is there's a massive savings in embodied carbon in not demolishing the existing vet med, right? And yes. So anyway, I think that would be an interesting bullet point to just show.
Sure.
And then thank you very much. And then Nate, don't misconstrue this question. I'm super excited about the passive house building that you are part of. But I am curious if a study's been done on the embodied carbon of the passive house strategies and how those passive house strategies embodied carbon compares to the hopeful operational carbon savings. you may not have that at the ready, but I'd recommend that as part of the discussion because I think it could be important.
Yeah, that's actually something we're doing as a part of our case study for Baker's Place. So I don't have the answer yet, but I hopefully will, and maybe we can come back in 6 months and tell you our findings. But we are looking at that because there's more materials, which is going to have inherently more embodied carbon, but then it's also like more intensive materials. And so I'm curious of that question as well. And hopefully this case study will show us the answer.
Wonderful. Thank you very much. Great presentations, all.
Thank you. I can answer Don's question if that's okay, Ben, or unless we need to go to a different question.
No, please. Yeah, feel free. Others, if you have questions, to raise your hand.
Don, so I think I understood your question, and maybe I'll clarify it just for everyone else if you're not looking at the chat. So essentially, Don is asking, what is our end of life assumption? And that's one of the things that we have a big question mark around. Right now, we're using the one-click LCA assumptions, which I don't have the exact assumptions in front of me. I can follow up here and show everyone, but I believe it's something like, I think 25% is reused, and then I think it's 75% is into a landfill, and obviously would decompose in the landfill. And so that's one of the questions we have is how can we build these buildings better so that they can be disassembled and reused at a higher rate? And that's another question we have that we're looking at in this case study that we're doing with USDA. And so again, I know I'm going back to this case study, but I think, Ben, we're going to have another session here in about 6 months where I come back and speak to it. But hopefully I have that answer for you guys of what we're looking at for end of life assumptions and how we maybe make those end of life assumptions a little bit better than they are right now.
Yeah, we'd love to have you back, Nate, obviously. Don, I see your hands raised. Why don't you jump in?
Yeah, I appreciate the comment, Nate. And I think as these presentations show, I think there's better understanding out there and a realization that depending on the project, particular materials will be a better fit than other materials, and there is no one right answer. So working with a combination of materials certainly makes a lot of sense. And as time goes on and as knowledge grows, being able to look not just at embodied carbon at the front end, which obviously is very important, but looking at the full life cycle and really understanding impacts over time, because I guess it was Ben that mentioned the idea that if you can keep an existing structure and not tear it down, that's the best way to avoid any of these issues. And certainly if we build them better to last longer, we'll go a long way to just improving the environment across the board.
Thanks, Don. Appreciate that comment. Kim Radine had a note in the chat. Chris, I don't know if you saw that for you. I will repeat it for the group. For a design bid build project, so likely where the architect, contractor are both at the table early, how can a team try to start working with manufacturers early enough to get low embodied carbon mixes figured out for a project?
I guess first of all, the required strengths, it's very important. If we already have EPDs on the shelf that the mixes would fit, which we very well could. We've got over 20 of them right now, but we're continually working on more. And the type of concrete, some concrete mixtures are less than, super high strength concretes and things like that, of course, are going to have a higher environmental impact. So part of the conversation is, if there's, say, exotic aggregates that aren't locally available, that's certainly a big issue. But just, a general conversation in most cases can probably clarify at least what can be done locally and in a timely manner.
Thanks, Chris. Got a few minutes. We got more than a few minutes left if there are other questions. Go ahead, Tim.
Yeah, Chris, one of the interesting things that we discussed earlier was, the transition to type 1L cement, and we're now going to go into the weeds a little bit. But I think that's an interesting piece of information to highlight as the decrease in the availability of 1 or 1,2 cement and the increase in the availability of 1L cement as a reduction, a reduction to be found.
Yeah, that's been significant in the 1-2 cements. There, we already in our market can't get them, so that is definitely a significant impact. And before long, you won't be able to get 1-2 at all.
Can you quantify just off the top of your head? I mean, is a 1L 5-6% somewhere in that range? Is that?
I'd have to go back and look through the EPDs. We did rerun several EPDs because of that. I know it was greater than a 5% difference, because once you get to a 5% difference, you're required to redo the EPDs. If it's less than 5% change, but I can't remember exactly what it was, Tim.
Cool, thank you.
Let me jump in on that if you don't mind. This is Kevin McMullen, Wisconsin Concrete Pavement Association. Currently, all of our type 1L cements that are being used in Wisconsin have ranged from around 11 to 13% limestone. I've seen it vary over the course of the construction season. And I will tell you that right now, all domestic produced cement in the Midwest by all of the manufacturers right now is 100% 1L. So virtually in Wisconsin, all of our supply is 1L cement, unless there is a foreign-based. We had some Turkish cement that came into Wisconsin last year that was a type 1 cement. So our market is almost virtually 100% 1L at 11 to 13 is where I would tell you we're at.
Go ahead, Don. Don, you had your hand up. It looks like.
I'm sorry, I was muted.
No, you're all good.
I just wanted to clarify, when we're talking about type 1L cement, we're talking about a cement that incorporates or intergrinds up to 15% limestone in place of Portland cement. And if you go to that full, or if the full 15% component is available, you're reducing your embodied carbon footprint of the ready mix by 10%. So the percentages that were just mentioned obviously are pretty close to that 15. So you're automatically, or you're getting a reduction in your embodied carbon of your concretes on the basis of type 1L being kind of the standard cement that's now available.
Hey, this is Julia. I just want to jump in. Don, would you be willing to introduce yourself really quick? I know you've been very involved in this effort with National Ready Mix Concrete Association and Building Innovations, and I believe with the Concrete Innovations resource, which we have shared on our website because it has so many great details about different ways that this that concrete can have lowered embodied carbon. Could you introduce yourself really quick, just because you've had a lot of comments and you've offered a lot of insight on this?
Sure, glad to. I'm Don Thompson. I am Senior Director of Building Innovation for the National Ready Mix Concrete Association. I support our Build with Strengths program, which is a program to dispel myths and just provide accurate information about topics like we're talking about today, and ready mix concrete's role in these issues. Our Build with Strength program is something that was established about 6 years ago to just better educate the construction industry, and I cover 8 Midwest states, including Wisconsin.
Thank you, Don. Well, unless there are any other questions, I had one slide I wanted to finish with. I think, every time this group gets together, I'm kind of humbled by the detail we get into and the diversity of topics we're all engaged in. So again, I would love if you all would continue to engage with the Carbon Leadership Forum hub here in Wisconsin, continue the conversation. Hopefully this has sparked some follow-ups for what you could be doing in your practice day to day, someone you could reach out to, something you could be looking in to a little further, and definitely bounce ideas off Kim, Julia, or myself if there's ways that the CLF hub can help be a platform to collect and share that information with others. So that's what we're trying to do and what we're hoping to do more of. So we had one last few announcements here. So we had a focus groups kickoff, which you can see the 4 square bullet points were the subject topics that we kind of got groups together and had, unfortunately, a relatively short conversation about how those specific subject matter topics could maybe be moved forward and further delving into. At this point, we're definitely looking for leaders in the industry in Wisconsin to raise their hand if you're interested in leading a group. What that would likely mean is facilitating conversations, taking some notes, and like a little extra effort than just showing up to the meeting. We'd manage that so it's not a huge haul, but if you think that's a leadership role you'd be interested in, we'd love to hear from you. Ultimately, we're trying to get follow-up to those discussions so they don't linger too long, sometime in April. So if you're interested, please follow up with Kim, Julia, or myself before the end of next week. Obviously, it'd be an option moving forward, but for that next discussion, if you can let us know by end of next week, if you're of interest, it would be great. We'll look for more educational sessions here in April, May. Some may be borrowed from other hubs or the CLF proper, but definitely keep a lookout for that. Obviously, LinkedIn is the best spot to be in touch with what we're doing. And then, as Julia mentioned earlier, our website is live and we'll continue to update that. So 12:59, thank you everybody so much for coming. Julia, Kim, anything else from either of you?
Thank you. Just we're all glad to see you here, and feel free to spread the word that Carbon Leadership Forum Wisconsin Hub is a thing, and that we are always open to anybody joining for any of our events. So help us spread the word and raise more awareness. Thank you.
Yeah, thanks to our presenters, Nate, Unni, Chris, Tim. Appreciate all your time to put this together. Have a good day, everybody.
Thanks everyone.
Thanks all.
Thank you.